you're in grade 11, and I typed up the notes package for you, I had you guys fill in the notes packages, I taught you the content, and you guys were doing the content pretty fluidly at the, like you guys were like, your retention of the individual skills was solid when I was teaching them to you, right? So you've got filled in notes packages, you've got podcasts. I've given you 10 review questions every weekend that you should have been doing to support your long-term skill development. And then I gave you like 3 cumulative reviews. In a pre-calculus class, I don't study for you, and I'm very intentional. I'm moving on today. I will address questions you have based on your own studying, but I am not going to review for you. I will not study for you. That is not the way pre-calculus is. You guys have to have independent study habits. So, is there anything from cumulative review 1, cumulative review 2, or cumulative review 3, or any 10 a week that you guys would like me to address? Because if there's something that you've come across and you don't know how to do it, here's your chance to ask me. But if you didn't study over the weekend, I can't do anything about that. Like you guys have to recognize that you guys are not. So when you look at this, we've had 15 10 weeks. Actually, there's actually been 16 because I had a part A and a part B for the first one. So there's actually been 160 questions posted. And then I gave you cumulative review number 1, cumulative review number 2. Studying is in your hands. It's not in mine. Any questions at all from any of the cumulative reviews that I gave you guys last week? When you're doing a cumulative review handout and you come across something you don't know how to do, what do? You go back to your notes and you review the notes. Like, make sure that you guys are actually studying. I will not study for you. I'll give you guys the tools that you can use to study, but I will not study for you. So you guys are telling me there's not one question that you guys want me to do. Yeah? On cumulative review number 3. Okay? So guys, question number 1, cumulative review number 3. Is this the one you're looking for? Okay. Okay. So remember chapter 1. So everything's kind of in order. This is chapter 1. This is chapter 2, and it kind of goes through. So it says a concert hall has 10 seats in the first row. The second row has 12 seats. If each row has 2 seats more than the row before it, and there are 30 rows of seats, how many seats are in the entire concert hall? So guys, when you're looking at this, that's like T1 has 10 seats, right? And T2 has 12 seats. And it says if each row has 2 more seats, then T3 would have 14 seats. Do you guys see that this is arithmetic? This is not geometric. Because we're going up by 2. And remember, if you're adding a common difference, so we're adding D, so D is equal to 2, then it's going to be arithmetic. And then when you look at your formula sheet, this isn't just asking us for, and we actually go to like T30, because there's 30 rows. It's not asking us for how many chairs are in row 30. This is saying how many chairs we have in total. So we're finding the sum of the first 30 rows. And when you look at your formula sheet, right across the top is your arithmetic sequence. Those are the ones with the common D, common difference. And then the second row is your common ratio. Common ratio means we're multiplying as we're moving to the right. So if you're finding the sum of the first 30 terms, the formula you use is this. And then it just becomes like a plug and chug into the formula, and your calculator will do the order of operations for you. If you type this whole thing in, you're going to get all of the chairs that are in the concert hall, and you'll get your sum 30, and then you'll say, therefore, there are blank chairs in the concert hall. And if you don't give me a sentence statement, and it's a written response question, you lose that half mark. And you would just, like, you'd fire that whole thing in. And even if I had my old calculator, so 30 divided by 2, start a bracket, 2 times 10 plus, instead of saying 30 minus 1, I'm just going to throw a 29 in there because I know that 30 minus 1 is 29 times 2, right? And I'm finding the sum of every row in the concert hall. So we have 1,170 chairs or seats in the concert hall. Yeah? So guys, if it's arithmetic, there's a common difference. If it's geometric, there's a common ratio. Are there any other questions from those that you guys would like me to address? So I've given you a lot of potential questions for you to work with. Your cumulative exam is on chapters 1, 2, 3, 4, 5, and 6. Any questions at all that you guys want me to address? Okay. I'm going to give you guys one more. I'm going to give you guys only 15 minutes to work on it. We're moving on to the next skill. And remember, guys, in 30-2, for sure, you've got class time to study. I even give practice tests the day before. 30-1, there is no homework time or studying time. You wouldn't even get time to do this in a 30-1 class. 30-1, all the studying is in your hands. Tomorrow, if you're concerned about not having enough time, you come at lunch, okay? So guys, if you want to start your test early, come at lunch. This is the last cumulative review that I'm giving. If you come across a question and you have no idea, look it up. So guys, question number 1 is from chapter 1. Question number 2 is from chapter 2. So that's trig. Question number 3 is from chapter 3. Question number 4. Usually one time per class. Oh, what's per class? Yeah, we're safe. Okay. Okay. So guys, just start working on those right now. And if you're feeling lost, guys, last week we started chapter 7, and it's absolute value and reciprocal functions. And we started to dive into this idea of asymptotes. And the asymptotes are the first feature that you're going to have to graph when you're dealing with reciprocal functions. Okay? So last week we kind of explored that the non-permissible values for x turn into vertical asymptotes, right? So we found the NPVs. So in rational expressions, we would have NPVs. Those become the vertical asymptotes. Does everyone have their notes package to take it out? Okay. And then I showed you like a massively doable method for finding the non-permissible values for y. And then after that, I was like, hey, let's just memorize these 2 steps. If your degree on top is less than your degree on the bottom, your horizontal asymptote is going to be the x-axis. If your degree on the top is the same as your degree on the bottom, so when I look at this guy right here, this is a degree 1 on the top, this is also a degree 1 on the top. When the degree on the top is the same as the degree on the bottom, your horizontal asymptote is going to be the quotient of the leading coefficients. So what I showed you last Friday was, we can isolate for the variable y, for the variable x, and then we'll be able to find the non-permissible value. If you just memorize these 2 steps, you don't have to do that algebraic process ever. Okay? So NPVs for x give you vertical asymptotes. Horizontal asymptote is going to be based on the degree of the equation. Okay? So we started working on this. You have today to know this because we're going to be this stuff is going to go fast. Okay? So what we did is we approached this equation from the front. And I always grab my horizontal asymptote first. So I look at the equation, I see the top was degree 0 and the bottom is degree 1. Whenever the top is less degree than the bottom, your x-axis is going to be your horizontal asymptote. The equation y equals 0 is the x-axis. And so we had a horizontal asymptote at the x-axis. You label the horizontal asymptote as y equals, and it becomes a dashed line that you get infinitely close to, but you will not touch. which means we are never going to touch the x-axis. There's not going to be an x-intercept. And then you come back to the equation and you find your non-permissible value for x. X can't be 2, which means I'm going to have a vertical asymptote at x equals 2. So I'm going to draw this line, x equals 2. Those are the two lines that the curve is going to get infinitely close to, but it's not going to touch. Now I'm going to show you what this looks like in the equation. So if you're like, we're just going to 1 over, was it x minus 2? Okay, so there's the function. That one doesn't look too bad. I can actually see that I'm going to get really close to the x-axis and never touch it. And I can actually see that I'm going to get really close to x equals 2, but I'm not going to touch it. If I try to trace 2, it gives me nothing. It won't give me anything for the y. So I'm just going to erase that so you guys can see that. There is no y value that will come. But if I go like 2.0001, as soon as I'm just slightly to the right of the asymptote, it's really, really high, but it does exist. Do you guys see that? Like, so if I'm at 1.9999, really close to 2, but it's not 2, the y value exists. If I go 2, it doesn't exist. It's one instantaneous non-permissible value. That's one vertical asymptote. So graphing these functions, guys, this is all 30-1. Now, if there's no x-intercept, because there's a horizontal asymptote at the x-axis, there's not going to be an x-intercept. We're never going to cross the x-axis. When I say y-intercept, you need to think x equals 0. So if you put 0 into the equation, you get your y-intercept of 0 and -1/2. For the rest of the ordered pairs, you might use your calculator to get a table of values. So maybe you're going to grab a few more. So maybe I want like nice, neat integers. Those ones are not going to become nice, neat integers. Okay, so 1 and -1 is nice and neat. 3 and 1 is nice and neat. I would plot those nice, neat ordered pairs. And if we're going to be bottom left of the asymptotes, then we're going to go diagonally across the asymptotes and we're going to go top right. Okay? This vertical asymptotes tells me what x can never be. So this is where the NPVs come into play. They come into play when you're defining the domain. And then here, I'm never going to touch y equals 0 because there's a horizontal asymptote there. So that's going to dictate my, so this horizontal asymptote is my NPV for my range. Okay? So we're going to try this guy. First move, I need you guys to determine the horizontal asymptote. So when you come in, you look at it. What's the degree on top? What's the degree on the bottom? Are they the same? What's the degree on the top? 0. What's the degree on the bottom? When the degree on top is less than the degree on the bottom, your horizontal asymptote will be the x-axis. What's the equation of the x-axis, ladies and gentlemen? What's this equation? Guys, that's y equals 0. It's just, this is y, where y is 0, and it's always 0. It doesn't go up or down. So your horizontal asymptote will be y equals 0. And the reason why, Braden said it. He's like, the degree on top was 0. The degree on the bottom was 1. When the degree on top is less than the degree on the bottom, right away, horizontal asymptote y equals 0. Put it in there. So always approach your equation first looking at the degree. Okay? Now, what would my NPV for x be? When you look at this rational expression, what's the NPV for x? X cannot be what? X cannot equal -3. So right away, I'm going to do a quick NPV. X cannot equal -3. We just had a whole unit on rationals that was like this. If x can never equal -3, then my vertical asymptote is the equation x equals -3. I have to plot this vertical line that we're going to get infinitely close to, but we're never going to touch, and I have to label it. If you don't give me the label, you don't get credit for it. So I've got x equals -3 as my vertical asymptote. I've got y equals 0 as my horizontal asymptote. Always plot your asymptotes first. Always determine your asymptotes first. Guys, will we have an x-intercept? If we have an asymptote on the x-axis, will we have an x-intercept? No. So there's no x-intercept. due to asymptote. Guys, whenever the degree on top is less than the degree on the bottom, there's going to be no x-intercept. Now, if I say y-intercept, what are you thinking? Okay, if I put 0 in for x here, so here's my equation. Y is equal to 1 over 0 plus 3. Guys, what would 0 plus 3 be? Do you guys see that my y-intercept would just be 0 and 1/3? Okay, 0 and 1/3 would be right about here. Not now. I'm in the middle of instruction, just not now. Okay, this is way too important. Okay, so guys, from here, I might actually type this, and I'm going to bring it into my old calculator. Some of you guys have 83s. This unit is miserable for your 83s. If you've got an 83 calculator, I'm very sorry for you, okay? Because when you type this in, you have to put 1 divided by, you have to put brackets around your denominator, so the x plus 3 needs brackets. So you have to put brackets around your numerator, brackets around your denominator, you type it in, and it just looks really nasty. Like it's really hard to determine what we're working with here. But what you can do is you can get a table of values and you can try to grab a few more ordered pairs. So I can see the 0 and 1/3. Maybe I'm going to try to find like, okay, -2 and 1. That's a good one to plot. So -2 and 1. And then maybe I'm going to grab another ordered pair, -4, -1. So what I can see here, because of my y-intercept, I'm going to get it. Do not cross your asymptote, and you have to take it to the edge of the grid. You can't cross your asymptotes, but you've got a curve in the top right-hand corner, and you've got another curve in the bottom left-hand corner. Your calculator is not smart enough. Like, it's trying to show you where the asymptote is, but it doesn't show getting infinitely close to. It doesn't stop. It's not supposed to stop. Okay? Like, if we have a -3, if I were to trace -3, it won't give me anything. But if I go -3.1, it gives me something. It's just actually, it's way down here. And there's my -10. So you sketch your graph, but you always label your asymptotes first. You want to if you try to algebraically, watch what happens if I try to algebraically determine my x-intercept. So if I put 0 in for y, and I solve for x, and I try to bring this up by multiplication, guys, what's 0 times anything? Can I say 0 equals 1? Is that a thing that works in math? No, it does not exist. 0 will never equal 1, so don't ever say that. So it does not exist. Like, there's no x-intercept due to the asymptote. Now, this vertical asymptote connects to my domain. This is how we state NPVs. In Math 30-1, you don't really talk about NPVs. We talk about restrictions on the variable x, and then we talk about resulting domain, and we talk about resulting range. And this is where you would say y can never equal 0. Y is an element of the real number system. This is when you have to be smarter than your calculator. Your calculator is going to give you stuff that doesn't look right, and you have to be smarter than your calculator. So your first move is to always figure out where the horizontal asymptote is based on the degree on the top and on the bottom. Okay? I'm going to do one more, and then I want you guys to do one. If you were to try to type this into your calculator, and you had an old calculator that couldn't do fractions, you would have to put brackets around the top and brackets around the bottom. Brayden, what's the degree on the top? What's the degree on the bottom? Okay, when the degree on the top is the same as the degree on the bottom, the horizontal asymptote is not the x-axis. Okay, when the degree on the top is the same as the degree on the bottom, we take the quotient of the leading coefficients. Okay, so when I look at this, I'm just going to rewrite it down here. Because the degree on the top is the same as the degree on the bottom, we take the quotient of the leading coefficients, and I say my horizontal asymptote is y equals 2 over 1, which is 2. So on Friday, we solved for the variable x to find the NPVs for y. You don't need to do that. When the degree on the top is the same as the degree on the bottom, we find the quotient of the leading coefficients. This is degree 1, this is degree 1, which tells me I have to divide the leading coefficients. 2 divided by 1 is just y equals 2. So I'm going to graph y equals 2. Yeah? Okay, that's your first move. You decide, and you've memorized it, right? If the degree on top is less than the degree on the bottom, it's the x-axis. If the degree on the top is the same as the degree on the bottom, we divide the leading coefficients, which was 2 divided by 1, which gives me 2. Now, I have to find my NPVs of x. X plus 4 cannot equal 0, so x cannot equal -4. My vertical asymptote is x equals -4. Don't call it an NPV. The asymptote is the equation of that vertical line. So this was Friday's lesson. We've got x equals -4. There's my vertical asymptote. You plot your asymptotes first. Will we have an x-intercept this time? Can we cross the x-axis this time? Okay, there's no asymptote there. So for my x-intercept, I'm going to do it in blue. Okay, so if I say x-intercept, what are you guys thinking? Okay, so y equals 0. If I put 0 in for y here, and then I need to solve for x. If I bring this, so this denominator, I'm going to bring it up by multiplication, guys. What's 0 times x plus 4? 0. Can I still solve for x? Divide by 2. What's 0 divided by 2? Do you guys see that this is both an x-intercept and a y-intercept at the same time? If you had done y-intercept, that's where x equals 0. And then you'd have y is equal to 2 times 0, 0 plus 4. And you would have 0 divided by 4. And again, you would have gotten 0 and 0. 0 and 0 is both x-intercept and y-intercept. Okay, everybody type this into their calculator. I don't know what calculator you have. Type it into your calculator as your y1. If you've got the old guy, you're going to have to put brackets around your denominator. So I'm going to show you how nasty this old guy looks. So I would have to put brackets around my numerator divided by brackets around my denominator, because I can't do stacked fractions, I don't think, in this calc. Can I? Math? Okay, hold on one second. Y equals? Second y equals? No, that's step 5. Alpha y equals? Alpha y equals? Yeah, this guy's too old, it won't do it. Okay, so this is an 83 plus, guys. You guys, I think, all have 84s. I think there might be 183 in the room. Okay, so guys, when you're looking at this, it looks horrendous. It actually looks not as bad as the last one, right? I can see where the vertical asymptote is. I can, if I trace 0, I can see my 0 and 0. Push zoom standard. Okay. Okay. I'm going to grab a few more ordered pairs before I sketch my graph. I'm just going to see. So -3, -6. So -3, -6. Maybe I'm going to grab a few more. What about -2, -2? Like, if you have the graphing technology, you should definitely use it. And then maybe 0 and 0, and maybe I should go a little further and see if I can see another nice, neat 4 and 1. 4 and 1's a good one. Okay. So I just got infinitely close to both of those asymptotes. I took it to the edge of the grid. I need a couple ordered pairs on the other side of that asymptote. So I'm going to find what, there's the error. There's the vertical asymptote. Like maybe -5 and 10, maybe -6 and 6. I'll throw -6 and 6 in here. So -6, just make sure, what I want you guys to kind of imagine is equidistant. So you have to think of it like rotational symmetry around where the asymptotes intersect. Like if this is my distance from the curve to where the asymptotes intersect, I want that distance to be about the same. So there's rotational symmetry around where the asymptotes intersect. If you just gave me this curve and not this curve, that's a completely different function. That's actually more like a logarithmic function. You have to give me both pieces. Now I'm going to come back. My domain is where I state the NPV. So I say x such that x cannot equal -4. X is an element of the real number system. And then here, y such that y can't equal 2. Y is an element of the real number system. If you wanted to, you can try to get to the -4. If I trace -4, it won't give me anything. But if I go a smidge to the right, it gives me something. If I try to get to y equals 2, okay, so let's see if I can, I'm going to try to make my graph hit the y equals 2. It's going to take a long time. But no matter how long I move my cursor to the right, it's never going to hit y equals 2. Like it's getting closer to the 2, but it's never going to touch the y equals 2. You can keep trying and trying and trying. It's not going to happen. Okay? So, you need to know how to manage asymptotes before you ever look at the graph. This is when you have to be smarter than your graphing calculator. I would like you guys to try this one. Where is the horizontal asymptote on this guy if the degree on the top is degree 1 and the degree on the bottom is degree 1? Where would the horizontal asymptote be? It's an equation. What's the equation of the horizontal asymptote? Okay, horizontal asymptote is always y equals, what is the y equals? Guys, what's the quotient of the leading coefficients? What's 1 divided by 1? Okay, you have today to memorize this. Okay, so you're going to say y equals 1. When the degree on the top is the same as the degree on the bottom, you're going to take the quotient of the leading coefficients. And then, guys, what's my NPV for x? Okay, then my vertical asymptote is x equals -1. We need to put those in and label them. If you don't label them, you don't get credit for them. It's part of the graph. These are your critical features. Take a minute, find the x-intercept, find the y-intercept, state the domain and range, and accurately sketch the graph. Guys, what does x plus 1 become when you multiply it by 0? It becomes 0. 0 equals x. If you wanted to do the y-intercept, it would have been y is equal to 0 over 0 plus 1. What's 0 divided by 1? Grab a few more ordered pairs, at least one more ordered pair that's going to guide your thinking. So when you weren't here Friday, that's why I'm making you stay for this. Okay? Like, I need you to know this stuff, and you already missed a whole, like, hour-long block. Guys, what other ordered pair did you grab? So when I graph this, even in my old guy, I just have to put brackets around it. You have to know how to use your technology. Guys, if you've got an 83,
and you're planning on taking 30-1 next year, you might want to upgrade your calculator, okay? Like just the 83 is not good for logarithms, it's not good for rationals, it's not good for a lot of reasons, just so you know, okay? So even though this looks nasty, I can still grab a couple ordered pairs like -2 and 2. Make sure you get infinitely close to the asymptotes and you go through the indicated ordered pairs. Did you guys show top left, bottom right in your sketch? Did you take your curve to the very edge of the grid? Trying these questions is never an option, ever. Do you understand that? Do you have all the answers now?
Yeah.
Domain and range, you sketch the graph?
I don't domain and range yet.
Okay, keep going. Okay. Domain and range and the sketch needs to be accurately drawn, ladies and gentlemen. These get more complicated in Math 30-1, ladies and gentlemen. So this is entry-level rationals, and next year we take it way further. Okay, look at the next rational. Always look at sketches.
Poorly on the sketch, especially because I like
Across the asymptote.
by accident,
Okay.
yeah. Like that.
Let's not do this. Okay. Guys, let's take a look at the next one. Is the degree on top less than the degree on the bottom? Or are they the same? Do you see that the top is degree 0 and the bottom is degree 2? When the degree on the top is less than the degree on the bottom, where's my horizontal asymptote? When the degree on top is less than the degree on the bottom, where's the horizontal asymptote? Okay, it's at y equals 0. When the numerator top of the rational equation is less than the degree on the bottom, degree 0, degree 1, degree 0, degree 2, it's going to be y equals 0, the x-axis. You have to memorize that. You just have to take your time, you memorize it, you have today to learn it. Okay, so right away, horizontal asymptote is y equals 0 because the top degree was 0, the bottom degree was degree 2. This is the x-axis. If we have an asymptote at the x-axis, will we have an x-intercept? So if we've got this line that we're going to get infinitely close to and not touch, we're not going to have an x-intercept. So there's going to be no x-intercept. Next year there will be, but it gets more complicated next year. Can you guys see the NPVs on this one for x? What do we have to do in order to find the NPVs? We factor the denominators. We would find the NPVs of every rational expression by factoring. What gives you a product of 10 and a sum of -7? That's -5 and -2. In factored form, this would be x minus 5, x minus 2. What are my NPVs? X cannot equal 5. X, guess what, guys? We've got two vertical asymptotes. We've got one at x equals 2. We've got another one at x equals 5. So, vertical line at x equals 2. Another vertical line at x equals 5. So the first thing you have to do is you have to state, where's my horizontal asymptote? We're not going to cross the blue line and we're not going to cross the green lines. So maybe let's just take a look at the function. I'm going to use the not nasty calculator. I'll show you what it looks like in the nasty calculator in a second. Okay. If we go back to the original, okay, so I'm just going to write x squared minus 7x plus 10. Even the new calculator does a really poor job of this, okay? So, We had a horizontal asymptote. And guys, remember, by calculus, you don't get a calculator. So if you're highly dependent on your calculator to look at the graphs and interpret the graphs, it's not going to go well in calculus, right? Like you don't get a calculator. So we have to know the critical features. On my NPVs where x could not equal 2, which means I'm going to have a vertical asymptote where x equals 2. And then I'm going to have another one where x is equal to 5. Now the calculator likes to give the impression that it can't keep going. It does keep going. This is when you have to be smarter than your calculator. You have to take it all the way to the edges of the graph. So your calculator is entirely flawed. It can't handle getting infinitely close to. So from here, all I'm going to do is I'm going to take a look at my table of values. And I'm going to see if there's any nice, neat ordered pairs that seem to stand out. Like maybe like 1 1/4. I don't know, 3 and -1/2. 4 and -1/2. There's nothing really that stands out as like an exceptional graph. So I'm not going to get too wrapped up in it. I'm just going to make sure that I go top left. I'm stuck in between on the bottom, and then I'm going to be top right. You don't have to be technical about the ordered pairs. So what your calculator is telling you to do is it's telling you to, oh, I should have found y-intercept. Guys, when I say y-intercept, what are you thinking?
0.
X equals 0. If I put 0 in for all those x's, so 0 squared minus 7 times 0 plus 10. If you put zeros in for all those x's, you end up with 1/10. So I've got 0 and 1/10. So 0 and 1/10 is really close to the x-axis, but I'm not touching it. Get infinitely close, and then infinitely close again. And then we go diagonally across the asymptotes. We're infinitely close. Do not cross the asymptote, and then come back around. So we're going diagonally across, and then again we go diagonally across. So the only thing your calculator does not give you your asymptotes well. What your calculator will kind of give you, it'll show you you're going to be top left, bottom right, and then top left again. Sorry, top right. Top left, and then we're going to go diagonally across. We're going to be bottom, middle, and then we're going to be top right. If you look at this one's even nastier when you have double asymptotes. So this is 1 over. So if you've got this old guy, it just kind of looks like a heartbeat. It doesn't look like anything, and it doesn't give the illusion that these get infinitely close to. It doesn't show you going on forever. It just looks nasty. But what you can get out of this, if you adjust your window a little bit, like if you go like -2 and then maybe 7, and if I adjust it just a little bit, I can see that I'm going to be top left, bottom middle, and then top right. Like just enough to see where I need to go. What would my domain then be? We can't be 2 or 5. Both NPVs need to be stated. X can't be 2 or 5, and then X is an element of the real number system. There's 2 NPVs. This is where the NPVs get stated as part of the domain. And then this guy is just a Y such that Y can't equal 0. Y is an element of the real number system. And these are not easy. And this is why you have to be smarter than your calculator, because your calculator kind of gives you gibberish, right? Can I get you guys to try this one? Always come in, approach it from the front, compare the degree on the top and then on the bottom. If the degree on the top is less than the degree on the bottom, where's your horizontal asymptote? Guys, what's the degree on top? What's the degree on the bottom? If the degree on top is less than the degree on the bottom, where's my horizontal asymptote? X-axis, so we say y equals 0, which is the x-axis. And if the x-axis is an asymptote, there will be no x-intercept. And remember that your vertical asymptotes come from the NPVs of x, right? So you have to factor your denominators. You need to state your NPVs.
Are you finished the question?
Yeah. The two NPVs. If there's two asymptotes, there's two NPVs. Guys, make sure you're drawing an accurate sketch. Asymptotes have to be dashed lines. They can't be solid lines. Do not draw them as solid lines. They are lines that we get infinitely close to but do not touch. The way we indicate them is a dashed line. You'll see the same thing in Math 30-1 next year. If you decide to go Math 30-2, which is a brilliant academic course as well, you won't be dealing with this at all. And I will never take the calculator away. Guys, you had to factor the denominator to find the NPVs. You should have had x minus 3x plus 2, and therefore x could not equal 3, and x could not equal negative 2. You have two vertical asymptotes based on those two NPVs. Did you guys have those labeled correctly? And it can't be a solid line. You don't get to just change the way we show things. This is how we show the vertical asymptote. Okay, where are my vertical asymptotes? I've got one at x equals, don't say cannot equal, it's a vertical line, and x equals negative 2, and x equals 3. When I say y-intercept, what are you thinking? And this would be a critical feature that you would actually determine. Do you guys see that we end up with negative 1/6? So 0 and negative 1/6. So it's going to be right about here. I'm going to use the old guy, and I'm going to just see where I need to be, like in terms of where the curve should be. So this is x squared minus x, and then minus 6. Okay, I've got brackets around my denominator if I've got the old calculator. I can see the asymptote at x equals 3. I can't really see it over here, so I'm just going to adjust my window, maybe make it go from negative 4 to 7. So I can see top left, middle, bottom. So just show that you're never going to cross the asymptote. As soon as you cross an asymptote, we're in trouble. Get infinitely close to, go around and hit that y-intercept. And then if I'm in the bottom between these asymptotes, bottom middle, I'm going to be top right here. Okay. Domain. X such that x cannot equal negative 2 or 3. X is an elementary real number system. Range, y such that y cannot equal 0. Y is an elementary real number system. How does this feel? It's complex, but you basically need to know how to graph rational functions accurately after today. Yeah? Okay. Guys, go to the whiteboards.